Hello, fellow Java developers. Welcome back to our starter course on Apache Camel. In this video, we will take a look at testing Apache Camel routes. We will make example of both unit test for a camel route and integration test. Let's begin. For this video, we will use a new camel project that you've seen many times already. We have POM-XML with camel core and login dependency. We have main class that creates and runs our camel context. And we have just one route that reads file without deleting it, transforms file contents to uppercase, and writes the result in the output directory. First, we will create a unit test for this route, testing its behavior that is between start and the end of our route. In unit test, we want to check that our transformation or routing logic works as intended, but we leave actual reading and writing messages to the integration tests. To create our unit test, first what we need to do is to add test dependency. It is org Apache Camel camel gunit5 dependency. Let's add camel test gunit5, and we have our Maven project property as our version. So let's download this dependency, and now when we have it, let's create a package for our gunit class. It will be the same package as we have for our route. So we have our route in camel.examples.route, and we have our unit test for this route in the same package. It is not a requirement, but just a good practice. Let's call our test example route test, and when we have it, let's start with basics. First, what we'll do is create private static camel context. This is because camel routes cannot be run without the context itself, even in tests. And to initialize it, we use gunit before all annotation. Here in this setup method, we create camel context, we start it, and we add our route to it. Just let's create a new example route here, and we're good. Of course, after the test, we would need to stop the context. Now, let's create an initial structure, or in other words, a skeleton for our route. You'll see what I mean in a second. In Camel, any route has some form of input, which is from statement, and might have one or more outputs, which is to or 2D statements. In other words, camel routes always have at least one consumer endpoint and might have one or more producer endpoints. This means that to test our route without our components and endpoints logic interfering, we need to somehow get rid of them. We need to make our route work without them. And for that, Camel testing framework uses mock endpoints. Let's create one. We will be mocking output file endpoint. So we create our toFile output mock endpoint. Let's close this tab. We don't need to browse our files for now. Here we're asking CamelContext to create mock endpoint. This is just its ID. It can be anything. Let's call it example route toFile output. And what we can do with this toFile output is, as idea already hints us, we can create conditions like that. And after our conditions are created, we can check them with assert is satisfied. So basically, what's happening here is we're creating our mock endpoint, we're telling it that we expect one message and its contents should be hello world. And after that, we're doing our assertions. Of course, this will not work as it is, because currently no one is sending to that mock endpoint. So what we need to do is we need to somehow obtain copy of our route that sends to our mock endpoint instead of its original output. This is done with AdviceWith class static methods, which can be used to replace endpoints in our route. To AdviceWith method, we need to provide camel context, ID of our route, we'll get to that in a second, and our route modification in the form of AdviceWith route builder. So what we want to do is we want to intercept the message that is sent to this endpoint and redirect it to our mock endpoint URI. And let's also make it a field so that we don't have to write it all the time. So it's that, and let's delete the quotes that we don't need. And let's actually name it so that we knew what it is. And let's put it in our to statement here. And here we need a semicolon. So what we've achieved with this configuration is that all messages that are coming to this endpoint are intercepted and sent instead to our mock endpoint. And to do that, for a particular route, we've used route ID, which is for now hard-coded as route 1. This is because our route does not have an ID, but Camel assigns it automatically, and because we have only one Camel route in our context, we don't have to guess. But this is of course bad practice. What we should be doing instead is assigning our route its own ID. And let's make it public static final string route ID. Example route is okay. Let's use it in our route ID DSL element. And we can also use it in our AdviceWith method. This is how usually routes are referenced by ID. Now when we've done that, we may try to run our test. Let's just replace it with to uppercase and run it. And while it ran, I saw that I forgot to replace this hard-coded endpoint URI with our constant. By the way, is this final? It should be. Now it is. And it works. But it works because we have hello world.txt in our src main resources directory, which is read and then sent to this endpoint, which is in our test, is actually our mock. This is of course unacceptable. If we change any contents here, it will fail. And of course, we cannot provide inputs for many other components with just our file system. For example, if we've had from GMSQ or Kafka here, a file from file system wouldn't have saved us. So to make it an actual unit test, we also need to replace from endpoint with something that we can control in our unit test. This is done with the same AdviceWith method that takes exactly the same parameters, but now what we'll do is we'll use replace from with statement, which is used to substitute consumer endpoint of our route. Here we are using direct component, which just allows to send to that direct endpoint from our code or from another camel routes. Usually it is used to call one camel route from another, but in tests it is used to substitute an initial route from statement, so that our test is decoupled from an actual component and endpoint that are used to consume data. Now, when we've done that, let's actually also make this endpoint a variable so that we don't have to type it anymore. And let's call it direct example route test. Now, when we have a route consuming from this direct endpoint, we need to send to that endpoint. And for that, we'll use yet another new Camel component, producer template. Let's call it producer, and we can get it from our Camel context, as it is with most Camel related things. So, what producer template does, it allows us to send messages from our Java code to Camel endpoints. For example, I can do just producer send body. Here I'm specifying an endpoint, which is our substitution of this from consumer endpoint, and we need to specify a body. So let's make string test body equals this by world. Let's also make it uppercase here and put it here to our producer send body. And let's run our test. And as you can see, it runs normally. So what we actually did is we basically created a copy of this route, but with replaced from and to statements, which we've changed to this direct and mock endpoints. And then we used producer template to send our body to our route's input, and we used mock endpoints conditions and assertion mechanism to ensure that our route works properly. This is how most Camel routes unit tests are done. First, we're identifying our route's input and outputs. Then we mock our outputs and replace our inputs. And then we use mock's assertion mechanism to check our business logic. And one more thing I would like to add before we move on is that here I've used static Camel context and before all method to set it up, which of course works when we have just one unit test. But if you have several test methods in your test class, remember that JUnit framework might execute them in parallel, and if you have static Camel context configuration, your multiple test methods might interfere one with another. And in this case, of course, it's better to have non-static Camel context and replace before all with before each, and then make it also non-static. So this configuration is more common when you have multiple unit test methods. So this is all fine, but don't you think that this Camel context creation, starting and stopping will be repeated in each of such unit tests? Well, you're right. In fact, most what we did here are repeated in each Camel test. For example, getting mock endpoint or creating producer template. To make all this test class have less boilerplate, we can extend CamelTestSupport class. I'll show you what it does in a minute. First, let's copy this test class so that we have it for our history. And let's call the new one example route test with support. Here we will extend CamelTestSupport, and what we can immediately do is delete this Camel context because it will be managed for us. We don't need this after all method. Here, instead of getting our mock endpoint from Camel context directly, we can just call get mock endpoint, and let's use the same mock endpoint we used before. Here, instead of creating producer, we can just use it. Oh, but it's not producer method, it's template, but it does the same. It gets you a producer template. And here we don't need our camel context start. Here we also don't need it. And what we do instead of before all method in CamelTestSupport extension, we are actually overriding another method that this CamelTestSupport has. So let's delete static and let me see. Yeah, we need this before test execution that accepts extension context. Here we change our signature, and as our overridden method actually has some tracing logic in it, we will want to save it, so we will call super method, and here instead of camel context we can just use context method, and the same with another AdviceWith. So the last thing that remains is to specify which route exactly do we want to test. And for that we override yet again superclass method, which is called createRouteBuilder, and here we just return our example route. Now this whole thing should work. And as expected, it all works as planned. So, comparing these two test classes, we've achieved the same result. We've tested our business logic with mock endpoint and assertions, but in this class, all management of camel context is handled by these CamelTestSupport methods. As you can see, we get our context from the context method, we get our mock endpoint from getMockEndpoint method, same with template, and we don't need to create, start, stop, or otherwise manage our camel context. So our test class is a lot better. But there is more. If you don't like extending CamelTestSupport and overriding its methods, then what you can do is use JUnit 5 extensions. In particular, JUnit 5 Camel extension. To add it, oh, by the way, forgot to add scope test here. Yeah, that's how it should be. Don't forget to add scope test to your tests dependencies. So what we need is CamelTestInfra-core, and for that dependency we need to add type test jar, and after it's downloaded, let's again copy our initial test. Let's call it example route test with extension, and here instead of using our camel context directly, we can declare protected static CamelContextExtension. Let's call it, well, CamelContextExtension, and let's create it right here with default CamelContextExtension implementation, and of course we need to mark it with register extension annotation. Now, of course, we don't need to create our camel context, but what we will do is we will get it from the extension itself. But actually we don't need to do that here. What we need to do here is make it context fixture annotation. Here it should accept camel context. Now we have it, and we actually don't need to start it, and also we don't need to stop it. And to add a route, we're using a route fixture annotated method, and same as here, this actually doesn't have to be static, so we can just copy this signature and rename method to create route, or even better, add route. And here we will just again create our example route class. Now this throws an exception, so we'll add it to signature, and we have our route creation. Now we can get our mock endpoint from CamelContextExtension. We just need to provide our mock endpoint name similarly to our CamelTestSupport method. And here, instead of accessing camel context, again we can just get producer template, And now, when we have everything set up, let's run our test to ensure it works properly. And, as expected, the test is green, so we can move on. Basically, we did the same as in this class extending CamelTestSupport, but with JUnit extension rather than inheritance. This extension method of writing unit tests is mostly used in older applications, and this JUnit extension is more modern. Now, after we set up unit tests, let's look into integration tests. First, what we will do is we add CamelContext dependency, because making integration tests with just files component is not very interesting. So let's add CamelContext. Let's use the same version as we have in our main project, and now when we have it, let's copy our route. Let's call it Kafka example route, and here, of course, we will change ID to Kafka example route. Here we will use Kafka. Here let's change it to lowercase, just to have something different in our processing logic. And here, instead of this, what we will do is we will actually specify our topic with this property. And we will do the same with broker's URL. Just use an application property for that. And let's call this property broker's string. Now, you can read about Kafka component and its endpoints URI format in an official documentation. Link will be down below. But basically, here we're specifying our topic using this property. And here we're specifying our broker's addresses, again using the same property. And let's also make our destination a property with something like Kafka route file path. And let's name our file with file name property. So basically what this route does, it connects to Kafka broker specified in this property, reads from a topic specified in this property, and then after making contents of the message lowercase, it writes them to the file, which is located at the path specified by this property, and file name is specified by this file name property. And I forgot to do one thing, and what I forgot to do is to add value deserializer, which equals to org Apache Kafka common serialization string deserializer. And let's fix a typo here and here. So what this does, it tells Camel Kafka component which deserializer class to use for consumed Kafka messages. As we will be sending text messages to our Kafka topic, we will use string deserializer to consume our messages. And let's also add log like received from Kafka and body, so that we know that we've consumed our message. So, to integration test this route, we will need a Kafka instance deployed somewhere, and then we will need to check our file system for the result files. In older days, this was done by spinning up an actual Kafka instance with all the fuss that comes with it. But today we have test containers, and Camel actually adopted them and made them very convenient and easy to use for Camel integrations. So, to make use of that Camel test containers Kafka, we need to add this test-infra-Kafka dependency. And by the way, Camel has this test infra for many systems or software elements that you might want to integration test your routes with. For example, Elasticsearch, AWS, and many more. We will add our Kafka dependency, use the same camel version, and all of these camel test infra dependencies should be imported as test jars, so we leave it here. And now we have our camel test containers Kafka dependency, so let's load it, and while it's loading, let's create our test class. Let's call it Kafka example route test. And what we will do immediately is we copy this CamelContextExtension, because we'll need it to run our route. But this extension is not the only one for this test. What we actually add is another extension, which is Kafka service. Let's call it Kafka service, and it is actually created by Kafka service factory. And let's use a singleton service, as we need only one Kafka instance. So what this extension does is it uses test containers to create a Kafka image in Docker and provide us with Kafka configurations of this Docker container. The next thing we have to do is to add context fixture. Let's call this method setup properties, so it accepts camel context. And then here what we need to do is, as we already know from working with endpoints video, get properties component. No, that's not what we need. We need to get properties component. Yeah, and let's call our properties file application integration tests properties. And because test containers create container with random port, we would need to override this connection string property. Yeah, let's create a new properties object. Let's put Kafka service get bootstrap servers. This get bootstrap service method returns connection string of this Kafka container, and our property name is here Camel Kafka route broker string. Now when we have it, let's get our properties component again, and let's override this broker string with our container's address. Yeah, and as we added context fixture, we can also add route fixture public void create route. It should accept camel context, and here inside this method we can add our Kafka example route. When we have this in place, let's actually make variables for our Kafka topic, and then for file path and file name. It's private string file name. And in our before all JUnit method, we will set up these properties. So for that, again, we need to create properties object. And the easiest way to do this is to make it through getResources as stream method. And we need to rename our application properties file. And after we did all that, we can now assign our variables. I forgot to make them static so that they can be accessed from this static before all method. So let's do this and do the same with file path and file name. We just need to rename our properties, and here it will be file name. Let's check it. Yeah, it's file name here and file path here, and we have file path here, file name here. Looks alright. Now what we also want to do is to make use of private static Kafka admin client, which you might be familiar with from Java applications working with Kafka. This is purely Kafka client's component, and it is not related to Camel. So to create it, let's add another before all method. Let's make it public void static. Let's call it create Kafka admin client. And here again we need to create properties objects. And what we need to put here is actually Kafka admin client dot. Oh no, it's not Kafka admin client, it's admin client config dot bootstrap server config, and we get it again from our Kafka service with get bootstrap servers method. And when we have it, let's create our Kafka admin client with Kafka admin client create and pass our properties. And what's wrong? Okay, here we need to actually specify admin client, and now we have it. And we also don't need this exception here. Now what we need to do is to create our properties file. It's called application integration test.properties, and here in this file let's put our properties. Topic will be test topic. Broker string will be anything, we will override it anyway. So it can be localhost. Now file path should be, okay, let's make it src test resources files Kafka, and the last one will be file name, and it will be something like kafka.test.txt. And after we have it, we can at last start writing our test cases. So first, what we'll do is before each test case, we will actually clean our topics. So let's create a method clean topics, and inside that method we will use our client to delete topics, and we'll pass list of our topic string, which I remind you we got from our property. And let's write our test case. Let's call our method test Kafka example route. Here we will have some test body. Let's put by world here. And for our test we will need producer template. Oh, it's a typo, it's template, which, as we already know, we can get from our extension. And let's call it producer. Oh, and let's fix this typo. And to check that our file is created, we will need to use consumer template, which again we can acquire with getConsumerTemplate method. Let's call it consumer template. Okay, you'll see what it does in a minute. Now, as our action, we need to send our test body to Kafka. Let's make URI string for this producer template endpoint. Let's copy these brokers from here. And again, let's get our URI from Kafka service. So what will happen at this stage is that we will send our test body to our Kafka topic. It will be read by our Camel Route, processed, and written to a file. So what we want to do here is to receive our result file contents, which we can do with consumer template, which, as you might have guessed, reads data from the specified endpoint URI. And here, instead of Kafka topics, we'll use file path, and as a file name parameter we will specify our file name from properties. And when we have our result ready, we can make use of gunit5 assert equals method. Let's import it. Expected is our test body in lowercase, and actual is our result, because as you remember, we're processing our message by making it lowercase. So now it seems that we have everything we need. Let's make one final adjustment. Let's rename this class to integration test, and let's fix a typo here. And before we run our test, let's quickly check one more thing. Yes, here we need to actually get class loader to load these properties resources. And after we did all that, let's actually run our test. And as you can see, it runs normally, and in my Docker desktop I can see that it pulled the required images. And of course I cannot see containers because they are deleted after the test is run. So let's go over what we did one more time. So we have our route for which we need to write integration test. First, what we did is we added this test-infra-kafka dependency to use this Kafka service JUnit extension that is provided by Camel test infrastructure. Then we created our properties for integration test, created our extensions, configured those extensions with our integration test properties, and in our test we've used producer and consumer templates to first send our message and then to receive the result. So this is basically how most integration tests with Camel look like. They use the test infrastructure required, which is usually based on test containers library, but not always. For example, RTMSMQ service uses embedded RTMSMQ, but most of the times it's test containers under the hood. Then we configure our camel context and route. Then we initialize any properties or objects we need for tests, and then we run a test itself. It looks a bit complicated, but after you do it several times, it becomes much easier. And with that, here's the end of our video on Apache Camel routes unit and integration testing. Thanks for joining. Be sure to like, subscribe, and hit that bell icon. And if you have any comments or questions, leave them down below. I will answer to all of those. See you in the next video. Until then, happy coding!